Welcome to the third part of the training session on CMEMS biogeochemical products for the Baltic Sea. In the two previous parts, we have learned how to plot maps of biogeochemical parameters from the monthly CMEMS product for a selection of dates, for a regional zoom, and for the whole period that was contained in the product. Then we saw how to plot time series of the biogeochemical parameters at different points in the Baltic Sea from the monthly CMEMS model product. In this notebook, we will focus on how to plot vertical profiles of the biogeochemical parameters at different points from the monthly CMEMS product. So first, as usual in Python, we need to import all the required models. In this notebook, as in the previous one, we will only need the OS, Xarray, and Matplotlib libraries. So let's import them. In this step of the training, we keep working with the CMEMS biogeochemical model monthly products. Except that this time we are going to work with two different files. One file containing the bioparameters value in March 2017 on every depth level. There are 56 depth levels. The other one is the same product with the same variables, but for June 2017. So, as I was saying earlier, the objective of this exercise is to plot the vertical profile of the biogeochemical parameters concentration at 4 different points for 2 different periods. Those 4 points are the same that we worked with in the previous video. The 2 different periods are March and June 2017. So, as we did in the previous steps, we first need to define the directory where the data is stored, root path. Then we create 2 variables, fname1 and fname2, pointing to the netcdf file that contains the biogeochemical parameters for March 2017, fname1, and June 2017, fname2. We will focus on the chlorophyll and oxygen concentrations and on the nitrate and phosphate nutrient concentration. As we did earlier, we create the paraname array to store the 4 variable names to be able to loop over the parameters in the next cell. Last action is to check if the path where we are going to store our figure exists. If it doesn't, it's created. This path will be the same as the previous notebook. Cell 2 just opens each netcdf file and stores the content into F in 1 for March 2017 and F in 2 for June 2017. It also prints the time frame in each product. You can see that the date in F1 is March 2017, and the date in F2 is June 2017. Now we are going to prepare the data so that we can generate the plot in the next cell. Keeping the same logic we had in the previous notebook, we create the two arrays, long-pt and lat-pt, in order to store the longitude and latitude coordinates of the 4 points we have chosen. Then we need to select the closest point to each defined point in the cmems product. We do it with the cell function of xArray. Now everything is ready for the plot to be generated. So cell 4 creates 4 figures, 1 figure per point, with 4 subplots, 1 subplot per variable on each figure. For each point and each variable, it will be possible to see the vertical profile of these variables for the two different dates, March and June 2017. So first, we loop over the 4 selected points. For each selected point, we create 1 figure with 4 axes, 2 lines and 2 columns. Then for each point and on each figure, we are going to fill each axe with 1 parameter for both dates, March 2017 and June 2017. And then we set all the axe properties. Eventually, we save all 4 figures in passout. Let's run this cell. So here is the first figure for point 1 with 4 subplots, 1 per parameter, and on each subplot the vertical profile of this parameter for both dates. And figure 4.2 organized in the same way, figure 4.3 organized in the same way, and figure 4.4. So for the analysis, let's focus on point 1, which is located in Gulf of Riga. So in March 2017, which are represented by dashed circled lines on the subplot. You can see that the phosphate and nitrate concentration do not change with depth. The oxygen concentration is also steady in the upper layers of the Gulf, while the chlorophyll concentration is close to 0. In June 2017, which are represented by the continuous squared lines on the subplot, the phosphate and nitrate concentration are close to 0 in the upper layers of the Gulf. These nutrients have been consumed by the phytoplankton, whose concentration is much higher in the upper layer of the Gulf compared to March 2017. This has a direct impact on oxygen concentration. While the oxygen concentration is rising in the upper layers of the sea due to photosynthesis, it decreases dramatically in the lower layers, where the dead phytoplankton cells sink and are being decomposed by bacteria, consuming much of the oxygen dissolved in the seawater. So this was step 3 of the training. Now let's move on to the fourth and last step of this training session.